Your ability to determine vertical asymptotes versus removable discontinuities in rational functions is something that is routinely tested on the ACT Math exam. So let's review vertical asymptotes and removable discontinuities. Vertical asymptotes are vertical lines of an equation toward which a function approaches but never reaches. They correspond to the zeros of the denominator of a rational function. Removable discontinuities, on the other hand, are single points of rational functions which forms holes in the graph. They correspond to common factors in the numerator and denominator of rational functions when set to 0. So on the right, we have the graph of f of x, which is equal to x squared minus 9 times x plus 2, all of that over x squared minus 4. It looks like in the graph we can see a removable discontinuity and also a vertical asymptote. The removable discontinuity appears to be around the point that has an x value of negative 2, and it looks like the vertical asymptote is at x equals 2. So how do we figure that out? Well, let's look back at the original function. To determine vertical asymptotes and removable discontinuities, let's rewrite this in completely factored form. So we can set this as equal to x minus 3 times x plus 3, because x squared minus 9 is a difference of squares. And then, of course, we can't forget the x plus 2, which is still there. And then in the denominator, we have an x squared minus 4, which is also a difference of squares. So we can rewrite that as x minus 2 times x plus 2. Okay, so for vertical asymptotes and for removable discontinuities, we have to look at the denominator. So when we set the denominator equal to 0, we would have either x is equal to 2 or negative 2. So which of those values is going to form a removable discontinuity and which is going to form a vertical asymptote? Well, we can see that x plus 2 is both in the numerator and the denominator, so effectively those terms are going to cancel each other out. Because they cancel, they don't appear when we have a simplified version of the function. So that's just going to form a removable discontinuity at the point where x equals negative 2. The x minus 2 term does not get canceled out anywhere, so that means when x is equal to 2, we are actually going to have a vertical asymptote. And that's what the graph does show.